Okay, chapter 8.3, question number 28. Find the area inside the circle r equals 1 and outside the cardioid r equals 1 plus sine theta. So to start, it's really helpful to graph these two equations so we can sort of see what we're working with. So r equals 1 is just going to be a circle with radius 1. So we can graph that pretty quickly. However, r equals 1 plus sine theta is not quite as obvious, so we can make a quick table to see what we're working with. So when theta is 0, r is going to equal 1. When theta is pi over 6, r will equal 1.5. When theta is pi over 4, r will equal 1.707-ish. When theta is pi over 3, r will be 1 plus the square root of 3 over 2, or about 1.866. When theta is pi over 2, r is going to be 2. And we could keep going like this on. And eventually we'd find that this shape looks something like this. All of it 2 and down. So we're trying to find the area inside the circle and outside the cardioid. So inside the circle but outside the cardioid is going to be this area down here. And it's going to be really important that we find these intersection points where the two shapes intersect. And to do that, we can set these two equations equal to each other, or 1 equals 1 plus sine theta. In other words, when is sine theta equal to 0? Now looking at the picture, we want a value that's going to be around here, or pi, and a value around here, 2 pi. And both these fit this formula right here, because when theta is equal to pi, or 2 pi, sine theta will equal 0. So those will be our limits. Now the formula for area is 1/2 times the integral of alpha to beta of f theta squared d theta. Now in terms of our problem, we're going to want the area of this circle minus the area of this cardioid from pi to 2 pi. So that's going to give us this area down here minus these two little pieces. So let's write that out. 1/2 times the integral from pi to 2 pi of 1 squared d theta. So that's the circle. Now we want to subtract 1/2 times the integral from pi to 2 pi of the cardioid, or 1 plus sine theta squared d theta. We can actually rewrite this as just 1/2 the integral of theta of pi to 2 pi of 1 squared minus 1 plus sine theta squared d theta. And we can plug this into the calculator to get an answer of about 1.215. So that is the area inside the circle r equals 1 and outside the cardioid r equals 1 plus sine theta.